Dang it! Why do I keep failing on my math test? Who is it?
My math test is our team lead. Are you having trouble with some math?
Yeah, I can't seem to pass my math test. I mean, I wish it was as easy as sports.
Well, actually, there's a lot of trigonometry in sports. Let me show you. Follow me.
Look, that's all CAF player, D. McLovin.
Hey, D. McLovin, can you come over here? You know, I used to teach that guy when he was a little pup. Hey, can you do me a favor and dismantle your bike? I want to show him how trigonometry is found in sports. Let me borrow that wheel for a second.
Yeah, man.
You see this wheel? This is a perfect example of how trigonometry is found in sports. So you see how the spokes cut up the circle into pieces? That's just like the unit circle. Hey, you want to play football?
Yeah.
I need to demonstrate to this guy how trigonometry is found in sports. So let's do this. Down, say hike. Hey man, get up. Your trigonometry was lacking there. So what you did there was you had a cut, but your cut was at a 90-degree angle. That's no bueno. You need to cut at a sharper angle. When you cut at a sharper angle, it allows you to give the illusion you're going one way, but in reality you're going the other. Next, your angular velocity was really slow.
What's angular velocity?
It's the rate at which an angle changes. So right there, your angular velocity was 360 degrees, meaning you spun one revolution against it per second. Yeah. And then what you need to do is you need to spin faster. To do this, you cut at a sharper angle. When you cut at a sharper angle, such as one at 40 degrees, they're able, lets you be able to spin
momentum,
faster.
right?
Yeah, it does. So then you'll be able to push off faster and spin around the defender. So
Okay.
want to try that out?
Yeah.
Do this. Down, say right. Good game. Thanks, D. McLovin, for the help.
Oh, it's no problem. Just doing what I do.
Are you gonna go now?
Yeah, I gotta dip out.
Okay.
Go
Thanks
do
for the help.
my pre-calc homework.
Okay. See you then.
Deuces.
Well, I see how trigonometry or math is found in football, but how is it found in other sports?
Don't you play basketball?
Yeah.
Well, trig is especially found in basketball. Want me to show you?
Yeah.
Let's go.
So how is math actually found in basketball?
Well, go take a simple free throw. I'll show you.
Okay, I'll use a completely ball that's immediately placed here.
We can actually figure out the mathematical equation of your shot. Because your shot traveled at a parabola, we need to consider three factors. First is your initial height. You release the ball at approximately 6 feet. Next, we need to figure out initial velocity. To do this, you need to shoot the ball, and I need to time you from when the ball first released, from your height of the, from when you first release the ball to when it hits the rim. So take your shot.
Ready?
Ready. So let's take a look at your shot. We know you are standing 15 feet away from the basketball hoop because you are standing at the free throw line. Now we time your shot from when you release the ball to when the ball first hits the rim. Your shot took approximately 0.625 of a second to hit the rim. Next, we need to do some math. So you divide the distance it traveled by the amount of time it took. In this case, it is 15 divided by 0.625, and when you do that, you get 24. That means the ball traveled at an initial velocity of 24 feet per second. So again, three key variables can influence your shot. First is the release height. We know your average release height is at 6 feet. The second variable that can affect your shot is the ball's initial vertical velocity, a rate which includes the angle and speed of the ball as it leaves your hand. Finally, the third variable is gravity, which makes the ball accelerate as it falls. We can combine these three variables to find the height of the ball at each point in time. We know the release height is 6 feet. We just calculated this variable and determined the velocity of your shot is 24 feet per second. And we need to multiply this number by time, or the variable t. Finally, the acceleration of gravity is negative 32t squared. However, in this case, we would only use a downward pull, which is half of it, so that would be negative 16t squared. Now that we know the three variables of the shot, we know we can figure out and set up a mathematical equation for the parabola. And once we do this, we could find the release, or we could find the point of the ball at any point on the parabola.
Oh, I think I heard about that. So can we find the max height using this equation?
Yeah, we can find the max height, and then we could compare it to other NBA players and see how you compare it to them.
Yeah, I heard the higher your shot is, like the better chance you have of making it.
Okay, let's do it.
Okay.
Okay, so you're right here, and you're shooting the ball, And the ball is going to travel in a parabola to the basketball hoop. You know, I'm a pretty good artist. They call me Michelangelo. And then from you to the basketball hoop is 15 feet. And the height of the basketball hoop is 10 feet. Now we know your release point is at 6 feet. And then, so this is initial height. That's the first variable we need to know. We have to remember the 3 key variables: initial height, initial velocity, and gravity. We just calculated initial velocity, and that was the upward motion of, and his shot was traveled at 24 feet per second. So we know that. And gravity traveled at negative 16 t squared, because we only need a half of gravity, which is the downward force of it. So now we could actually use these givens that we know and turn it into a parabola, a mathematical equation. We could write it in standard form. So negative 16 t squared plus 24 times t, because we need to multiply it by time, plus 6. And then we could use negative b over 2a to find the amount of time it gets to the amount of time it takes to reach the maximum. And since we're trying to find the maximum, this will work perfectly. So we plug in negative 24 over 2 times negative 16, and we get 0.75. Now this number is the amount of seconds it takes for it to get to the maximum. So if we were to plug this into the equation as t, we will get the maximum height of the shot. So let's plug it in. So negative 16 times 0.75 plus 24 times 0.75 plus 6. Alright, we need to square negative 16 times t, because that's the equation. And we get 15. So it equals 15 feet. So that means from here, or the peak of his shot will be 15 feet. Now we have to compare that to other basketball players, right? So Brian Scalabrine, also known as the White Mamba, shoots the ball at 14.75 feet. Your shot the maximum height of it was 15 feet. Now, we're not saying you're better than Brian Scalabrine because he's a White Mamba, no one can beat him. But we're saying your shot has a better chance of going in since your maximum height was higher. So, congratulations.
Yeah! Let's shoot higher than Brian Scalabrine. Woo! Hey, I heard you throw this ball hard enough, it'll travel through time and end up in tomorrow during the morning.
Really?
Yeah.
Assess that theory out.
Yeah. Hey, have you seen a basketball? Yeah, I was trying to do a PK, but it hit me, so I kicked it up.
Then where'd the ball go? I guess we'll just play some soccer in the meantime.
Okay, I'll be going, you kick, let's do it. Get out of here, man. Oh, wait, hold up, I need my mitts. I need my mitts. Come at me, bro. Let's go. Get out of my face. No.
Hey, do you need some help making a shot over that guy?
Yeah, he did the finger wag.
No.
Well, I think I can help you. I can teach you how to use trigonometry the way Just in Time taught me to. Here, let me show you.
Okay, so to solve your problem, we're going to use a function called inverse tangent. Now, to sum this up, let me show you what tangent is. So, what tangent does is you take an angle, let's say 35 degrees for example, and this angle will give you a ratio. It's approximately 0.7. Now, what inverse tangent does is you put in a ratio, so in this case 0.7, and it'll give you degrees, which will be approximately 35 degrees. So, in this same way, we're going to use it to solve your problem of how to shoot the ball into the goal. So you're right here, and the goal is 36 feet away, and this is the distance of a penalty shot. And the height of the goal is 8 feet. And the goalie is 5 feet, but when he jumps, he'll peak at around 6 feet. So we want to shoot the ball so that it'll go over the goalie, but still into the goal. And we'll pick 7 feet, just to give the ball a little room to make sure it doesn't get hit off the post. So our height here, or our opposite, is 7 feet, and our adjacent is 36 feet. So let's use inverse tan, and 7 over 36, and let's plug that into our calculator here. So we use, make sure you're in degree mode. Okay. And so we'll use inverse tangent of 7 divided by 36. And that equals about 11 degrees. So let's just draw the path of the ball. So you need to shoot the ball at 11 degrees in order for the ball to go over the goalie but still in the goal.
So you got it?
Yeah, I got it.
Alright, just make sure you shoot the ball at 11 degrees and you'll be good.
I want another shot. Man, I fell asleep waiting for you to get better. Here, let me get my Chef Boyardee glove. Let's go, let's do this. Here's the ball. Give me a best shot, come on. Power trick is too strong.
Wow, you really opened up my eyes to trigonometry today.
Okay, let's review what we learned. First, let's watch this video to increase our understanding of how we improved your football move with trigonometry.
One reason is because he cuts with his legs at about a 40-degree angle, on par with angles we've measured from All-Pro running back Arian Foster. But what really separates Jordan from the other edge rushers is his spin move. This agility is due in part to a ridiculous body fat percentage of only 3.8%. Jordan peaks at an angular velocity of more than 600 degrees a second.
So now that we watched that video, we now have a better understanding of how trigonometry can be found in football. So let's analyze how you did today in football. So you started with the cut that was at 90-degree angle, and it was evident that this was ineffective as you couldn't juke the defender. Next, you tried a spin move that had an angular velocity of a mere 360 degrees.
Yeah, but after you pointed out my trigonometric errors, I was able to improve. I changed my angle, my cutting angle of 90 degrees to 40 degrees, which allowed me to get more momentum and to fake the defender and make him believe that I was going one way when I was actually going the other. This momentum increase also allowed me to increase my angular velocity from 360 degrees per second to 720 degrees per second, allowing me to get around the defender and tackle you.
Second, we went to basketball and saw how math is found in this sport. We actually calculated the parabola of your shot.
Yeah, we found the equation of my shot's parabola to be negative 16t squared plus 24t plus 6. We discovered that my shot's max height is greater than Brian Scalabrini's.
Finally, we moved on to soccer and saw your progress in trigonometry. You even helped someone make a penalty kick against me using inverse tangent.
Thanks. Wow, there is a lot of trigonometry in sports. Thanks, just in time, or should I call you Leonardo da Vinci? I'll do much better in math knowing now how much trigonometry is in sports. Yeah!
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. You just can't sit. Gotta get tricky with it. That's it. 3 angles, 3 sides.